Okay, there it is. Ah, beautiful. All right, so in case you're watching this video and you did not hear what I just said, the scoring guideline is 6 times the number of correct, 0 times the number you got wrong, and 1.5 times the number you left blank. These 3 numbers should add up to 25, and the maximum score would be 150 points. So now let me explain the few cutoffs. So a few tiers, all right? So usually the cutoff for going to AMC is around 95 points. So if you can get like around 95 points on the AMC 10, you could probably go to AMC. Granted, you can definitely go to AMC if you have 105 points. So it's usually between 95 and 105 points. All right, the cutoffs for an honor roll, I think, is around 110 points. And the cutoffs for a distinctive honor roll, I think, is around 130 points. So a distinctive honor roll is top 1%, and an honor roll is top 2.5%, and AMC is top 5%. So this is for AMC 10. Okay, what did you guys get? I'll cut this part out of the video. All right, so here's the thing. Well, you guys only had around 45 to 55 minutes. So if you guys had the full 75 minutes, you guys could probably do like 3 to 4 more questions. So, I mean, if you guys work hard enough, I think all of you guys can get into AMC, all right? That's the goal. Now, the issue is we only have 1 week left, so it's gonna be pretty intense. All right, I'm gonna erase all this pretentious stuff. I mean, just do math for fun. It really doesn't matter that much. I used to think this was important. It turns out it's actually not that important. I mean, you'll still go to college even if you don't take this test. All right, this is not like the secret test that every person takes. All right, so any questions on the scoring procedures? No? All right, let's go with the actual questions then. Yeah. Do you want me to just run through every single question, or do you guys want to like give me like questions you had while doing the exams? So okay, between questions 1 through 5, any questions?
3.
3.
Just 3.
Okay. Can I have somebody's test? Sure. Is there an extra copy? Oh wait, here it is. Alrighty. 3, right? Okay. Okay, so you want to calculate 2021 over 2020 minus 2020 over 2021. Right?
Yeah.
Reciprocals. So what do you do with reciprocals? You cross multiplication, right? So it's 2021 squared minus 2020 squared over 2020 times 2021. Now what do you get based off the difference of squares? What is 2021 plus, okay, how do you factor this? It's a difference of squares.
Oh.
Yeah, so this is 4,041, right, over 2020 times 2021. So you should get 4,041 over something. Oh, okay, yeah, it's looking for P, so you go for E. All right, that was problem number 3. Any questions on that? All right, any questions on 4? If no, I'll go to 5.
No.
All right, 5. Okay, so, so for question number 5, n is 8 to the 2022, right? Okay, so we want to find n divided by 4. Well, 4 is a power of 2, so is 8. So what's the easiest way is to convert all these to powers of 2s. All right, so what is 8?
2 to the 3rd.
Yeah, it's 2 cubed, right? So it's 2 cubed to the 2022. All right, and we know that due to the property of exponents, we can multiply this in. So this is 2 times 6066. All right, this is n. All right, and then now we divide this by 4. So n divided by 4 is 2 to the 6066 divided by 4. What is this, guys, in terms of powers of 2?
264.
Yeah, 2 to the 6064, right? Okay, so now what is another way to express this number? Well, you could turn this into a power of 4. That would be 4 to the 3032, which is E. Or you could take it to 8 to the 1516, right? So yeah, you can go on and on. But the idea is to convert this to like a common base. and then you can do all sorts of fancy stuff. Sound good? All right. Between 6 through 10, any questions?
All of them except 10.
All of them except 10. Anyone else?
Yeah, all of them except 10. And if.
All right. How about? All right. Then I'll do all of them except 10.
Yeah, all
All
of
right,
them
okay.
except 10.
So the least positive integers with exactly 21. Okay. Okay, so number of positive divisors. Here's a quick lesson because this is on number theory, and number theory is not taught at Wheaton Academy. It's actually not taught in any high school curriculum, so it's normal that you guys don't know this formula. But to take the AMC, you guys should be aware of this. Is that so for some number that I can write as like 2 to the alpha times 3 to the beta times like 5 to the gamma. Why am I using Greek variables? It doesn't matter. All right, dot, 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 dot. So if it has like a prime factorization that looks something like this, then the number of divisors is like alpha plus 1. So we call this D is the number of divisors, right? Times beta plus 1 times gamma plus 1, on and on and on. So for example, like how many divisors does 60 have? All right, so quick question, 60, right? Factor 60 for me. What is the prime factorization of 60? What's the prime factorization? It's not the square root. It's like
Use like 2 times.
yeah, it's
2 times
2 squared times 3 times 5. All right, so the number of divisors using the formula should be what? 2 plus 1 times 3 plus 1
Oh, it's times.
times 5 plus 1. So it's, no, whoops, no, sorry. It's 2 plus 1 times 1 plus 1 plus 1 plus 1 because this is 3 to the 1, 5 to the 1. Okay, so this should be 3 times 2 times 2, which is 12. We can also bash it out and see if this is right. Okay, so we have 1, we have 2, we have 3, we have 4, we have 5, we have 6, 7, no 8, no 9, no 10, 12, no, yeah, 12,
Yeah,
15, 30, and 60. So 1, 2, 3, 4,
And
5, 6, 7, 8, 9, 10, 11. Okay, you can get another one. What?
20.
Yeah,
Oh
20.
yeah, and 20. All right, so yep, this formula works. Now remember this formula because this is important.
And, actually, just quickly on that one, in terms of procedure, when anyone's stuck on trying to find divisors, it's just good to put them in pairs, because, 1 times 16, be systematic about 2 times 30, 3 times 24 goes in 15, 5 goes in 12, and 6 goes in 10.
Okay.
So just go systematically like that, so you don't miss any. And when you do prime factors, if you want to use this formula here, so the way I like to organize the prime factors is like that. So that way, you don't have to try to do it in your head. It's less mental math and more procedural.
That's true, yeah, since we're going for accuracy here, so that's an important fact to be aware of. But anyways, we are looking for the least positive integer with exactly 2021 distinct positive divisors. Okay, so the number is written in the form of m times 6 to the k. So what is 6, guys? 6 is 2 times 3, right?
Yeah.
So it's m times 2 to the k times 3 to the k. And m is not a divisor, or 6 is not a divisor of m. That means neither 2 nor 3. Or actually, that means either 2 or 3 could divide m, or neither of them could divide m. All right. Well, it has 2021 distinct positive divisors. So, someone factor this? Okay. Actually, this is very tedious. It's 43 times 47. Do you guys see a quick way to do this?
No.
Okay, hint. 45 squared is 2025. Now do you guys see a quick way to do this?
Yeah, but I wanted to know
Yeah,
that.
but I would have known
How
that.
to do
Okay, well, it's a trick question. Okay, so just for the sake of, since they have a lot of problems that have something to do with the year the test is in, so just remember the prime factorization for 2023. I think it's 7 times something, 7 times 200. Let me just do it. 6 2 6 6 3. Yeah. So 7 times 289. 289 is a perfect square. right? 17 squared. So 17,
Oh, wow.
7 times
Yeah.
17 squared. A lot of sevens if you like sevens. All right. So that means we want to configure M2 and 3 such that you get this thing, right? You get 43 times 47. Now both of these numbers are primes. So how do you do this? Well, first of all, actually, I should never erase that, but yeah, 43 times 47. So we can do this by casework. Number one, M is not divisible by neither 2 nor 3. That means M has to be like a divisor of something else. Just assume that M is like some prime number to like the alphath power, right? Times 2 to the k times 2 to the k. There could be many primes, but let's just assume this is some random prime. Then this has to be alpha plus 1 times k plus 1 times k plus 1. But as you see here, since we want this thing to be 43 times 47, it doesn't really work out because you have 3 terms that are greater than 1. Okay? See, 2 terms here, both of them are prime. And plus this is a perfect square, like a perfect square obviously doesn't fit in there. That means M has to be either divisible by 2 or 3. Okay? Do you guys get that? Any questions? Should I go slower? Okay. That means M 2 divide M or 3 divide M. But they can't simultaneously be true because M is not a multiple of 6. Okay, so then that means M is equal to 2 to the like x times like another prime number or a bunch of other primes. But as we've sort of figured out, if you have like a bunch of other prime factors for M, that's not going to work out because you're going to have 3 terms. And 2021 is 43 times 47, that's only 2 terms. So that means M has to either be a power of 2 or a power of 3. Okay, 2x or 3y. Now, if M is 2x, then that's just 2 to the x plus k, and then 3 to the k. So we want to ensure that x plus k plus 1 is 47, and k plus 1 is 43. So k is 42, and x is 5. Alternatively, you could switch it around, and then k is still 42, but then y is 5. But since we're looking for the least positive integer, we should pick when m is a power of 2 instead of m is a power of 3 because 2 is less than 3. So then m would be 2 to the 4, right? Since m is 2 to the x. Oh, sorry. Yeah, 2 to the 4. I misspoke. I said previously 2 to the 5, but it should be 2 to the 4. And k is 42. So that would be 16 plus 42, which gives what? 58. So the answer is B. All right. Any questions on that? It usually shouldn't take that long, but since like this is like your first encounter with like number theory, this might take a bit longer. Alrighty. Okay, moving on. Problem 7. Okay. All right. Well, special fractions. I think special is now used not always in a compliment. Like say someone's special. Could be quite offensive, all right? So now it says A and B is special if A plus B is equal to 15. A and B are integers. Okay, they don't have to be distinct. So we can come up with a table of all our possible ABs. So we can 114, 213, 312, 411, 510, 69, 7, 8, 8, 7, 9, 6, 10, 5, 11, 4, 12, 3, 13, 2, and 14, 1. Okay, that's 14 possible available options. Okay, well, and then you take a closer look and you notice some of these simplify, right? 3 over 12 is 1/4. 5 over 10 is 1/2. 6 over 9 is 2/3. 9 over 6 is 1.5. 10 over 5 is 2. 12 over 3 is 4, and 14 over 1 is 14. And then let's go back to, what do they want? They want to find the number of distinct integers that can be written as the sum of 2, not necessarily different special fractions. So now that we know, we have a bunch of integers in here. So it's like, scam, psych, I'm actually an integer, actually not a fraction. So there's 14, there's 4, and there's 2 that are just integers. All right, so we've got 3 integers here. And then, basically, whenever we add 2 of them together, we always get an integer. And you can also add with yourself. So then you should get 3 times 2 number of integers, right? Since you can do like 14 plus 14, 14 plus 4, 14 plus 2, 4 plus 4, 4 plus 4, 4 plus 2, and 2 plus 2. Okay. And actually, just for the sake of distinguishing them, let's list them out. So 28, 18, 16, and then 8, 6, and 4. So these are our 6 integers that we can form with our given integers. All right? Now let's take a look at numbers with common bases. So we have 3 over 2 here. We have 1 over 2 here. We have 13 over 2 here. So 3 numbers with denominator 2. So we've got 13 over 2. What is this? 3 over 2 and 1/2. Okay. So since they have a common denominator of 2, first of all, we know that when we add them together, they just go to their numerator, right? So like 1/2 plus 1/2 is 1, etc. So the thing works again. You can basically just 3 times 2, right? And 6. So you think, oh, well, the answer is 12, right? Actually, no. You see, because 3 plus 1 over 2 is actually 2, so that, that was a bad example, but 13 plus 1 over 2 is, that's also a bad example. 13 plus 3 over 2 is 8, and 8 is already in our previous recorded numbers, so this is not distinct. But actually, this is the only not distinct number, so you just subtract 1, so you have 5. Okay, so the actual answer is 5 plus 6, so that's 11. Now, you might wonder, why can't we find any other special fractions that add up to an integer? Well, the answer is because you should look for a common base. We've iterated through the 1s, the 2s. There's only 1, 3, and then there's only one number after that has like a unique base. That's why you can't find a special fraction anymore. So the answer is 11. Do you guys have any questions with this? Yeah, sometimes you just have to list out all the numbers and then play around with them for a little bit. All right? All good?
Wait, but isn't 3 over 12 plus 11 over 4? Oh wait, 11 over 4 doesn't work. Never mind.
Yeah, no.
Yeah.
Okay. Any other questions? All right, we're gonna move on. Okay, problem 8. Problem 8 is actually one of the easier ones in these 5 problems. So 16 through 84 is to the 14, right? To the 4, and we're looking for the prime factorization essentially of 16,383, or 16,383. So that is 2 to the 14 minus 1, right? They gave you the factorization. That's very nice of them. Some brutal questions might not give you the factorization, and you might have to factor it yourself. So also just be aware that 16,384 is 2 to the 14. If you're into computers. Okay, so how do you factor this? This is the 3rd time this formula has come up today. How do you factor this? Difference of squares, right? So what is this?
2 to the 7 minus 1 times 2 to the 7 plus 1.
What is 2 to the 7?
128.
128. So what is 128 minus 1? 127. What is 128 plus 1? 129. Okay. Now, you might be, okay, so then let's go with 129. Well, 129, is 129 a prime number?
No.
No, what is it divisible by?
3.
Yeah, 3, okay, so divisible by 3. So 129 is 3 times what? 43, right? Yeah, 3 times 43. No. Yeah. Okay, that means, okay, then it's 3 times 43 times 127. Is 127 a prime number?
Yeah.
How do you know? Oh, okay, this is also general knowledge. How do you know if a number is a prime number? Well, there is, you can bash through numbers between 1 through 126 and conclude that none of them divide 127. This is computationally expensive. You would be a fool if you did that. Sorry. There is a better algorithm. Consider the square root of that. This is probably like 11 point something. So if no number greater than 11, or less than or equal to 11 divides this number, then this number is prime. Do you guys know why? Well, because you have to have factor pairs. Okay, so then we basically just have to search through the prime numbers between 2 to 11. So what is that? 2, 3, 5, 7, 11. 5 numbers. Okay, does 2 divide that? Obviously not. Does 3 divide that? Do you guys know the algorithm for 3?
Add the digits and if it's
Yeah, some of the digits. 5?
No.
Okay, if its last digit is either 0 or 5, then it's a multiple of 5. Okay, 7? You guys know the trick for 7?
I feel like I should.
Okay, 7 is a bit complicated. 7 is, so you truncate the last digit, and then you subtract twice times that.
Oh, that's right.
So, -2, well, -2 is not a multiple of 7. Sometimes when it's negative...
Go through that a little bit slower.
Okay,
Maybe do an example of it too.
okay, let's consider example 49, alright? We all love 49. 49 is what? Is 7 squared, right?
Yes.
Okay, so the algorithm is you truncate the last digit, and then you subtract twice times that for the remainder, or for the remaining number. So it's
So
4,
you truncate what?
the last digit.
Truncate the last digit, okay.
Mhm. And then you subtract twice times that from the remaining number. So the remaining number here is 4, and then you subtract twice times 9, so that is -14. Now negatives are also multiples, so -14 is 7 times -2.
Okay.
That's why it's in multiple of 7. Okay, we are running low on time, so we're gonna have to speed up again.
But it's okay, it's better to understand than to finish.
That is true. Did you guys understand the rule for 7?
Yes.
7 is interesting. Okay, 11. Is it a multiple of 11? No, it's not. Well, how do you know? There isn't.
121.
Yes, 121 is another one, but there's also a way to tell if a number is divisible by 11 by looking at its digits.
Oh.
So another rule here. Okay, 2 rules. You guys have to. You guys should know this. Okay. So is this number a multiple of 11?
Maybe.
Well, it actually isn't. I was trolled. Is this number a multiple of 11?
Yes.
Probably.
Yes, because it's 11 times 10101, right? 10101. Okay, but what are some traits to this number? Well, if we look at the sum of its odd digits, and by that I mean like this is okay. This is like the first digit. This is the second digit, third digit, fourth digit. Okay, first, second, third, fourth, fifth, and sixth. So if we look at the sum of the first, third, and fifth digit, and if we look at the sum of the second, fourth, and sixth digit, if their difference is a multiple of 11, then this number is a multiple of 11. You guys catch that? Okay, so,
Oh.
No. What?
okay, so, focus guys, you guys have to focus. So you and the camera, you guys have to focus, all right? This is important. So, to tell if a number is divisible by 11 or not, what you do is you start from the last digit and you start labeling them. You give them labels, but just their indexes. So this is the first digit from the right, second digit, third, fourth, fifth, and sixth. And then you look at their sums, okay? So for numbers on odd indices, you add them up. So on the first index, on the third index, on the fifth index, you add them up, right? For numbers on even indices, 2, 4, and 6, you add those up as well. And then you subtract them.
So it'd be
Okay.
3 minus 30.
Yeah, it'd be 3 minus 2, which is 0. And
Yeah.
0 is a multiple of 11.
Okay.
Okay, so 1 plus 1 plus 1 is some odd. 1 plus 1 plus 1 as well, and then you subtract them, all right? So SO minus SE, And if that is a multiple of 11, then this number is a multiple of 11. Okay, a buzz quiz. How do you tell if 121 is a multiple of 11 based off this method?
1
1 plus 1 minus 2.
Yes.
0.
Yeah. Okay, how about 132? Same trick, right?
Yeah.
Okay, you guys get it, right?
Yeah.
All right, so memorize these for 7 and 11. But after checking, you find out that, okay, 127 is not divisible by any of these, so it's a prime. Okay, so then we add the digits up, so it's 1 plus 2 plus 7, so the answer is 10. All right,
Wait, what?
since
Right?
you're looking for the sum of the digits of the greatest prime number,
Oh.
Yeah.
That's what that was the question.
yeah, okay, if you misread the question, I'm sorry. Make sure to read the question carefully because
Yeah.
they may have like double negatives inside the question as well, or like weird ways to phrase the question.
Yeah.
Yeah. These people probably didn't. Never mind. I shouldn't go off ranting though. Okay. Problem 9. Oh. Well, 7th of them are red. Okay.
Uh-huh.
And then 5/7 of them are blue.
Uh-huh.
Okay. 1/6 of them are magical. And the fraction of red knights that are magical is twice the fraction of blue knights that are magical. Okay, so you have a lot of magical red knights and you don't have a lot of magical blue knights. So the shaded areas are magical. What is the fraction of red knights that are magical? Okay, what?
1/6.
Okay, so this is 2/7 of them are red and 5/7 of them are blue, right? So we can like just use this diagram, right? This would length would be 2 and 5. Okay, we're looking at areas. We're looking at areas. This is just like probability. We're looking at areas. Okay, and if we give this, if we call this x, like the height of like the rectangle that signifies the number of red knights,
That's good. X.
red magical knights, and y, the area that signifies the number of blue magical knights, so you get 2x, right? This area is equal to twice times 5y. So 2x is 10y. All right, what is x is 5y? Well. What fraction
Wait.
of what? You guys good? All right. So now the question is, well, what is x in terms of this thing? Okay. Well, the good thing you know is that 1/6. So 1/6 of the knights are magical. That means that the two areas add up to 1/6. That means that this has to be
2/18, 1/9.
1/9. Yeah.
So then I thought the answer would be 1/9.
Well, no, it's what fraction of red knights.
Oh,
So it's 1/9
okay.
over
Yeah.
2/7. So that is 7/18.
Which is not an
Wait. Hold up.
Yeah, I got
2/3.
What fraction of red knights? Oh, it's still 2 lines of the red knights though.
What the heck? Wait. Is this a troll? Is this a troll, guys? Are we trolled?
Good job.
I think we are.
We should not be trolled. What?
Use magic.
Okay. Now, due to magic, we're gonna skip this question. All right. Either I somehow was screwed up, or it's just they didn't have the right answer, which is possible because this is from like a random website that I pulled up. This is not the official one. This is from ivyleaguecenter.org. All right, if you want to go to an Ivy League, you better visit ivyleaguecenter.org. This is not a plug. Okay, you guys want to skip 10, right?
Yeah.
Sure.
Okay, all right, 11. Are you guys confused with 11?
I got
I
11.
got it.
Okay, then we're gonna skip 11.
I was about to get 12, but then you got off the 10.
All right.
I didn't do it.
Okay,
That was the first
12.
test.
Yeah, 12 is actually an interesting one. So
I think I didn't read
1 minus z plus z minus x is what? All right. Well, you might want to factor this. Don't factor this. That would blow up your brains. So you're, well, I mean, if you really wanted to factor this, I don't know the factorization, so don't factor this. I didn't factor this. All right. So you have 5 options, and since you're looking for one option, right? You're looking for like an option that guarantees this. All the other 4 must not guarantee this. So you can just look through them one by one and then just eliminate the options that fail. All right, that's exactly what we're gonna do. A, x is greater than y and y is z. This looks like a no-brainer, no. Well, I mean, honestly, if y is equal to z, then cross off the middle term. So then it's just y minus x times y. So then it becomes x minus y squared. Right, but since x is greater than y, that doesn't guarantee that's equal to 1. Do you guys get that? Okay, so 1 is a no. All right, and then it's honestly the same procedure for B, C, and D. You guys get the idea, right? Since you can just substitute after that. Now, the only thing to note is that B and C are wrong, and D is correct. So when we get to D.
Wait, why?
What? Okay, let me show you why D is correct, okay? So when x is z and y minus 1 is x, so y minus x is 1. Okay, so y minus x, so x minus y is negative 1, so this is negative x. This term disappears, and this is y minus x, right? Y minus x is 1, so this is just 1. So this is y minus x. What is y minus x? Y minus x is 1. So, both sides of the equation, they match together. That's amazing, right? That's matter. Maybe that's where the remaining 9s went to. Okay, now, if you encounter another problem like this, you should know that since they would expect you to go through the options one by one, and they want to like take as much of your time as possible. So start from the bottom. It's usually like one of the bottom options. Yeah, it's psychology, right? Okay, questions on 13?
Yes.
Okay, all right, 13. And we are going to go till 5 p.m. All right. Is it? You guys have an issue with that?
No, that's what the message said.
Okay.
Or I might leave a little early.
Okay. Try not to leave early. I don't want to speak to like empty seats as if they were disinterested farm animals. All right. So you're given a diagram. It's great to have a diagram. In the case where you encounter a geometry problem and you don't have a diagram, always draw the diagram. It helps 99% of the time. And the 1% is when you drew the wrong diagram.
Hey, just one thing real quick. Ali, Andrea, I did send the links to register for the AMC, so should be in your on-campus message.
Oh, yeah.
Thank you.
Right.
Thank
To you.
Right. Bye, Ollie.
Bye.
Okay. So if you read the problem, it's a square with length 3, describing an isosceles triangle with one side, okay. Square with length 2, 2 vertices. All right, so what is the area of the triangle is what we're looking for. And the triangle is isosceles. That means, to be honest, only half the triangle is needed because it's symmetric. That's a fun idea, all right? So, do you guys know what similar triangles are?
Yes.
Yeah. Okay. So, this looks like some similar triangles to me.
Yeah.
Yeah, so, all right, let's label these, let's give them names. Let's just call this A, B, C, and this point here is D, E. All right? So, what is DE, guys? Since E is the midpoint of, like, yeah, it's 1.5 or 3/2. Okay, what is BC? Well, you don't really know. This is 1/2 plus something. Okay, what is BE?
3.
B is 3. Okay, let's give this a name as well. F and G. What is GE? 2. What is FG?
1/2. Oh,
No.
no.
1. All right. So we have 3 similar triangles. We have AFG, and a larger version of it is ADE, and an even larger version of it is ABC. Okay, so FG is 1, D is 3/2. So what is the ratio of their heights then? This should be 2 to 1, right? This is terribly off scale, but this should be 2 to 1. Do you see why?
Oh, yeah, yeah.
Because the ratio is 1 to 1.5, and then so like AG over AE is 1 to 1.5. That means G is 0.5 of AG, right? So since G is 2, then AG is 4. Okay, that means AE is 6. All right, AE is 6. You guys catch that? If not, I can do it again.
Wait, but isn't the
AE
is
is
the square length 2? So how did you get 4 for?
okay.
Oh,
Alright.
that's so off.
Yeah. I mean, I'm not a great artist, or else I should have applied as an art major. You know.
Wait, so are you saying that AG is 4 or that?
AG is 4 and AE is 6.
Oh, okay. AG is 4. Okay.
Let me just
Now I got it.
do this part. Oh, you got it?
Yeah.
Okay. Okay, now let's look at another two pairs of triangles. So ADE and ABC. All right, so AE is 6, right? You guys all caught that?
Yeah.
And EB is 3, which this is totally off scale. That means AB is 9, right? And so since these two triangles are similar, the ratios between DE and CB should be the ratios between AE and AB. So 6 over 9 is 2/3. That means CB is 2/3, 3 over 2. What the heck? That's perplexing. Oh no, it's 3 over 2 times 3 over 2, so it's 9 over 4. So BC
Thank
is
you.
9/4. Right, so yeah.
Yeah.
See mid?
Okay, so if BC is 9 over 4, well then that's the base, 9/4, and twice that is 9/2, right? So the base of the large triangle is 1/2, or is 9/2. The height of the large triangle is 9. So what is the area? What is the
1/2
area?
base times height.
Yeah. So evaluate it.
Is that 4 halves?
No, this is 9/2.
Oh, that's okay. 81 over 4.
Yeah, 81 over 4, right? But they want it in the form of like an integer plus a fraction.
So then 20
fraction. So 21/4. Okay, that was 13. Moving on. All right. Any objections? Oh yeah. Do you guys want me to go over it?
I mean, 14. I feel like even if we went over it, I wouldn't be able to get it in the future.
I mean, it's just probability.
It's just a crazy amount of trials.
I mean, usually you shouldn't be able to do, or you shouldn't have to do a ton of casework. There's usually like a simpler shortcut. Let's look at 14, all right, since we just went over probability.
Yeah.
The memory should be pretty fresh. Okay, so she rolls 6 6-sided dice and calculates the product of 6 numbers obtained. What is the probability that the product is divisible by 4? So your options are 1, 2, 3, 4, 5, 6 for every roll, right? And then you roll 6 of them. So you might think, oh wow, this must be some super large number, since it's pretty likely that you get like a multiple of 2 every time. It's a 1/2 chance you get a multiple of 2. All right, and then you have to do like a bunch of binomials and do a bunch of casework. Oh wow, so perplexing. Well, there is always a shortcut, and the shortcut is to find the probability of the complementary of that statement. So instead of finding the probability that the product is divisible by 4, find the probability that the product is not divisible by 4, and subtract that with 1.
Yeah.
So what is P? Product not divisible by 4. Okay. Then this is what we're looking for, and this is a lot easier. Why? Because, well, it should be a pretty small case. So then, really, you have 2 cases when it's not divisible by 4. The first case is it is divisible by 2. And the second case it's not divisible by 2. So either one of them could be correct. Actually, let me just, oh yeah, this is totally recorded. Okay, so when 2 divides the product, then you must have one die roll that is a multiple of 2. So you have 3 multiples of 2 here, including a multiple of 4. Now you don't want 4. All right, so you can either roll 2 or 6 for one roll, and then 1, 3, 5 for all the other rolls. Okay, now you're rolling six rolls. So you can pick one roll. It's a lucky roll where you roll a multiple of 2, but not a multiple of 4. What is the probability that you roll 2 or 6?
Like for one roll?
Yeah,
1/3.
1/3, right? You just got that right?
Yeah.
I don't know. Some people seem lost here. I hope I did not lose you.
Wait, is that 6 choose 1?
6
Or
choose
6
1.
over 1? Okay.
6 choose 1, yeah. What is the probability that you roll 1, 3, or 5 per single roll?
1/2.
1/2. And you want to roll this for 5 rolls. So
1/2 to the 5th.
to the 5th. Alrighty. Calculate that. What is 6 choose 1? What is 6 choose 1?
Just 6.
6, right? 6. What is that times 1/3?
2.
2, right? What is 2 times 1/2 to the 5th?
Oh, 1/16.
1/16. All right, so that's the case when 2 divides the product, but 4 doesn't. Okay, the other case is when 2 doesn't divide the product, so just no 2s. Okay, then you have to roll 1, 3, or 5 6 times. All right, what's the probability that you roll 1, 3, or 5 for a single roll?
1/2
1/2. So 1/2 to the what power?
to the 6th.
Do you guys catch that? Yeah, to the 6th. Okay, so what is that? What is 2 to the 6th?
64.
Yep, 64. So it's 1/16 plus 1/64. What is that?
5/64.
5/64. So this is the probability of the counter statement. That means the original statement, the probability of the original statement is 1 minus that. So the probability is 59/64. Okay. Yeah, so sometimes if you can already sense that doing it directly is very mind-bending, then just do it the other way around.
Yeah.
Yeah, or else you have to do like the case when it's divisible by 4, divisible by 8, divisible by 16, divisible by yada yada.
Yeah.
And that's just very mind-bending. Okay, should we move on to 15?
Yes.
Geometry. You guys should love geometry. You guys should learn to love geometry. Although I hate geometry, so I shouldn't be advocating for that. Now the good thing for geometry haters like me is that whenever you see a square, you can consider turning it into an analytical geometry problem by adding a coordinate plane.
Okay.
Now this might not be helpful, so I don't know. I didn't do this problem. I did not come in prepared, but okay. PQ line on BR is 6 and PR is 7. Okay. Oh, yeah, so you can definitely do this with analytical geometry, but it's usually slower than like regular geometry. So you have to think carefully whenever you decide going in. All right, but we're looking for the area of the square. And we really just need to know the side length because it's just the side length squared. So how do we find the side length? Well, let's observe the diagram. There's a right angle here, right angle there, another right angle here. So I think you can notice that you have a lot of similar triangles again. All right. So if we call the angle PBA alpha, then what is CQB? It's 90 degrees minus alpha, right? Since this is a 90-degree angle over here. Then inside the angle BCQ, if you know that angle CQB is 90 degrees minus alpha, and that there's a right angle here as well, then angle QCB is also alpha, right? And then you have a bunch of right angles. So you have a bunch of similar angles. There are a bunch of similar triangles. That's great. Also, notice that the right triangle PAB is similar to that. So you have like 4 different similar triangles, and the goal is to make use of that. So if you call the length of the square x, then well, first off, maybe we can do this with like trig. I think trig might be easier because since the angles are passed around, the trig values are also passed around. So cosine of alpha is x over 7 plus 6 is 13, right? Okay, that's cosine of alpha. Then cosine of alpha is also QB over 6. So that means you can equate that. Now the question is, what is QB? So if we can find QB, we can find x. This may be a harder process while it's situated in a larger context. QB. To be honest, maybe the Roman numeral method might help with this.
So what?
Just kidding. I'm saying that to appease you. Okay.
No, I mean, it sounded like you were telling a joke, but what was the wording of it? Because I was focused elsewhere.
Oh, to be honest, maybe the Roman numeral method would help with this
yeah.
problem.
I'm all for honesty.
All right. I don't think so, though, unfortunately.
I mean, because Roman numeral is best for optimization and related rates.
Yeah. You know. But do you guys want to do analytical geometry? I can't find the other equation.
We probably won't use it. Like,
Sure.
if we learn it once,
Yeah.
I feel like we could spend our time. Or
No,
what
just
is
like
it?
keep it in your back pocket.
You'll be the only one that uses it.
No,
I think I'm smart.
I mean, do you guys still want to do regular geometry? We can stick with it. I'll probably find it in 2 minutes.
2 minutes.
I mean, or we could just go into a different problem.
That's true.
Yeah, but that's not really my
That's
style. Wait, you guys actually want to skip? Because this problem isn't that hard. It's just you have to take a while to find it. I don't know. Do you guys want to do combinations or geometry?
Do something that we actually use.
Because generally, like, geometry is well, I don't know, it's personal preference. Like, I like combo better than geometry. So I would always choose combo over geo if I can. But,
Wait,
okay.
Is this on the same problem?
No, this is problem
Okay.
16.
Good. 16.
Okay, so you have 5 balls arranged around a circle.
Oh, yeah, this one.
Sylvia does the same, chooses 2 of her adjacent balls to interchange independent. Okay, their original positions after these 2 successful transpositions. 16. Okay, so there's 2 people, they switch balls, right, randomly. And so these 5 balls are, you could expect them to be different. In fact, let's just say they're different. Well, I mean, I'm not going to draw 5 different balls, so I'm going to write 5 numbers. Well, so boring, right? I know. Okay, so and then you pick 2 numbers and then you swap them. That's what you do. And what is the expected value of that? So well, here's what could happen, right? After Chris has swapped, so originally there's no change. Chris has to make a change, so he has to swap at least 2 balls. And in fact, you can only swap 2 balls. That's all that he can do.
Adjacent.
Yeah.
Yeah.
And they're adjacent, exactly. So he could swap, like, for example, 1, 2, since it really doesn't matter. All right, so then it becomes 2, 1, 3, 4, 5. And now Sylvia gets to choose. All right? So, if she happens to swap 2, 1 again, then that just goes back. That goes back to square 1. All right? The probability of that happening out of how many pairs do you have? You have 1, 2, 3, 4, 5.
Yeah.
So there's a 1/5 probability that you just swap it back. You just put it back. Nothing happens. And then there is and then you think about it, right? So if you swap like any other pair, then it always messes up the configuration. So for example, if you swap like 1, 3, then it becomes 2, 3, 1, 4, 5. And so you keep like 4 and 5 intact. So the question is, how many numbers can you mess up from their original squares, from their original positions? And so if you switch like 2, 5 or 1, 3, then you're only like messing up 3 numbers, because one of these numbers is already like switched twice. And so this is the case when 0 numbers are switched.
It's asking that they occupy their original position.
Yeah.
So it'd be 5. Or at least I did it with 5. 1/5
Oh, yeah.
Plus, yeah.
Yeah. Yep, you're totally right here. Okay. So, and then the probability that you switch like, one of the adjacent ones is 2/5, and then you end up with 2, right? You see that? Like, for example, you switch 2 and 5, then you have 2, 5, 1, 3, 4. So 3 and 4 are intact. Okay, and then there's another 2/5 chance that you swap one of these 3. All right, so then you mess up 4 numbers, so there's 1. All right, and then so you add them up. This is 1, this is 0.8, this is 0.2. So the answer should be 2.0, which is C.
Well, it's
Oh,
it's 2.5 times 1 is 0.4.
Oh,
I think.
huh?
Wait, no, the bottom one. 2.5 times 1.
Oh, yeah, this is 0.4. Whoops. You see, arithmetic is hard.
Yeah.
So yeah, 2.2. But you guys got the idea, right?
Yes.
Okay. 17? Should we do 17 or should we wrap it up? We still have 5 minutes. We can do 17. Do you guys want to do 17 or 18?
And I got it right.
Oh, okay.
Well, I kind of got down to 2 options and I guessed they're right.
Okay.
So.
I mean, both of them are geometry. One's analytical and one's synthetic, I guess. By the way, synthetic geometry just means vanilla geometry, or like geometry with no special tricks, as opposed to analytic geometry where you get to use like coordinate planes and stuff. How about let's do 16 or 17?
Yeah.
Also, if you could get like the first 17 problems correct and just not do all the other ones, then you can at least guarantee an honor roll.
Oh my gosh.
Yeah. So the bar is not super high, and I mean, like if I did this test in 75 minutes, so I could probably get 20 plus problems correct.
Yeah.
So you guys can as well. You know, we're not that different. Okay. We have a coordinate plane here. We have the XY plane. There's the origin. Ooh. Okay. So there's some reflection going on here. There's P, and P is reflected over the line and becomes P prime. All right. Actually, I'm not going to draw the line since it might be misleading. And then P prime is reflected about M to P double prime. So you somehow reflect this to 4, 1. 4, 1 is over here. So this is -1, 4, 4, 1. And then you know that L is 5x minus y. So y is 5x. And then you first reflect it with respect to L, and then you reflect it with respect to x, or to M. So it should look like something like that. Well, let's break it down. All right, so you would expect P prime is like somewhere over here, right after the reflection.
Would it be in the first quadrant or the fourth?
It would be in the first quadrant since you reflect it like over here, and
Yeah.
then you reflect it over there. So you could like even start guessing. M should look somewhere like that. So the slope should be at least negative. So then you can eliminate it down to A and B.
D was the answer. So.
Wait. Wait.
I think the line is steeper than you imagine it to be.
Yeah, then it could be like that.
Yeah.
Oh, yeah.
Yeah.
No, you're right. Yeah. Whoops. Okay. So don't do what I just did. That was a bad example. Well, I mean, I would always calculate it since I probably have enough time. But yeah, so then it probably looks like something like that, or this. But the question is, how do you numerically compute reflection?
Yeah, I don't know.
There are formulas for that, just like designed for analytic geometry, that I have memorized, but I think it's like a hassle.
Okay.
So you can always resort back to like just basic geometry, and you can always solve this. It might take a bit longer, but you can always solve this. So what you have here is, just to explain this process, like, so y is 5x over here, and then you have p prime. P is 4, or negative 1, 4, and then p prime, you want to find the coordinates. Here's what you do. Here's the origin, here's p prime. This forms an isosceles triangle. All right? If we assume that the coordinates of this point is x and y, then first of all, OP is equal to OP prime. And secondly, there's a line, PP prime, that passes through P, right? So it would be then very, very handy if we knew the equation for this line. And actually, we can find this out. How do we do it?
Point slope form.
Point slope form, exactly. What is the slope of this line?
Negative 1/5.
Exactly. All right, so this line is slope negative 1/5, and it passes through P. So, negative 1, 4, right? So then, what is the equation? It's y minus 4 is equal to negative 1/5 x plus 1, right? That's the equation of the line. And now, we proceed to find the coordinates of the midpoint, M. Why? Because it's the midpoint. And you know the midpoint formula, right?
Oh, yeah.
Yeah. Okay. So, and then you find the midpoint, and then use the midpoint to find the other point.
Okay.
And then you repeat the same process, since now you know like the coordinates of 2 points. Then you can do that.
Yeah.
So, that's the idea. It's just doing this twice.
Okay.
Okay. All right. Does that make sense?
Yeah.
Okay. We are at exactly 5 p.m. I think we should get going. I can make I can make a video explaining problems 18 through 25 if you guys want me to. I think since we only have a week left, we should try more problems. We should actually like get situated into the
Over
mode.
to Wednesday, because it's Wednesday morning, so
Yeah.
technically that'd be Wednesday.
We have 5 days left. So, if you want to get better scores, honestly, another way to do it is asking if Mr. Royce can register for the B test as well.
Yeah, because that's overall.
We actually don't have that in the budget, so that's not an option.
Okay, so that is not an option.
Is there
Well,
like another practice test I could take? Or
Uh,
no.
Yes, go to artofproblemsolving.org.
Art of problem solving.org. Okay.
And they have all the previous contests. So,
Wow. Awesome. And the answers?
and the answers, yeah. So I would suggest doing contests starting from like 2011 or something,
Yeah.
because like tests from like 2 decades ago are considerably easier. In fact, I would suggest checking like tests after like 2019.
Okay.
So 2019 and later.
Yeah.
Because those tests are actually like, they actually match the current difficulty. So you have 2 tests every year. You have the A test and the B test. And if we had enough money, we could have taken both tests. But I also felt like it'd be good if we just took one.
Yeah.
It's like double the pressure.
So are they any like, is the B test any easier? Is it? or is it
No,
just-
it's around the same
Okay.
difficulty, but they will probably splice up the topics a little bit. So if you saw on like the A test, they had like more geometry, then they probably might have more algebra, more number theory on the B
Okay.
test. Never take my word for granted though, because
Yeah.
I did not come up with the questions. I will also be taking the test. I'll be taking a harder variant called the 12. I'm moving to the AMC 12, which just involves logs, trigs, public number, yada yada yada.
Thank you, Mr. Rose. Thanks, David.
Thank
Thank
you.
you, Elliot, have a good day, Andrea. Enjoy your
Thank you.
weekend.
Have a-
Yeah, so, yeah, I just say, if you have 5 days, like, maybe take like a practice test every other day or every day and just get situated into the mode. Most people can qualify, most people that grind for it will probably qualify for AME. I hope you guys do. I certainly hope you guys do. All right, bye. All right, yeah, go to AOPS.